Okay, here we are on page 2. This first one is a parametric equation. On the test, this could easily be something that's given to you as an angle and a velocity, so know your cosine and sine breakdown. But here it's done for you a little bit more easily. If you type that into parametric mode on your calculator, you're going to get exactly what you see here. This is gravity in meters, so I hope this is given in meters. Yep, it is. And so when you type that in, it gives you a sense that for every second it's going 20 meters to the right, and it's going up at 15 meters per second, but gravity is pulling it down. So when you go to the window, I typed in what I thought was sensible here. You expect these things to be, any projectile is going to be in the air for around 4 or 5 seconds. Maybe you'll make that 5. Your step should be like 1/10 of a second. Be careful if you're going between a degree problem and this type of a projectile problem to be sensible about that. I'm going to show a little bit to the left of the axis, so I go -5. If I'm throwing a lacrosse ball, maybe it could go, well, 200 meters, that's an awful long way. I think a lacrosse field is about 100 meters, so I'll do that. And then for the width, maybe I'll make it, or the height, maybe about 50 meters in the air. That would be a pretty high throw. And let's see if I got fairly lucky. That's pretty reasonable. I could zoom in on that certainly if I wanted to, but in the interest of time, I think I'll try to answer these questions. Hope that was on screen. There it is. If it was off screen, that's a bit ridiculous. But there's the window, and there's the picture. How high in the ball is at the greatest height? If I hit trace and then just zoom over to the highest point, it looks like it's around, on the Y, around 13.5 meters. So I'm just going to go to the nearest 10th. That's the height. How far does it travel by the time it is caught at a height of 1 meter? So I want to watch that Y value, trace over, and see when it's at 1. Right there. Whoops, right there. It's at 1.4, and it's gone 62 meters. So that's close enough. Maybe it'll go 63 meters, something like that. So you can do approximately. How long is the ball in the air from the moment it's released to the moment it is caught? The time there is 3.1 seconds. And then translate this into an equation for y in terms of x. I go to the first equation here and I solve for t. And if I divide by 20, I get t equals x over 20. So I then substitute that in right there and in right there, and I get y equals 2 plus 15 times x over 20 minus 4.9 x over 20 squared. It'd be great if you tidied that up. 15 over 20 is 3/4 or 0.75, so y equals 2 plus 0.75 x minus, well, 20 squared is 400, so this is going to be minus 4.9 over 400. We usually don't mix decimals and fractions, so you could make it 49 out of 1,000, and then that's x squared. That's a little bit awkward, but that's still good. So then sketch the graph, and it's going to be something like this. And you could label the appropriate parts, you know. Label that, if that's the highest, label that, and show the window dimensions, -5 to 100, and -5 to, what did I say, 60, something like that. Okay. On problem number 6, it says solve the following triangles. So you're going to find all the missing sides and all the missing angles of all possible triangles. So if you wind up with one that's an ambiguous case, you want to find both of those triangles. So this one is a side problem. That's about as straightforward as you can get. If you sketch it out, I'd make the longer side on the bottom. It's just a little bit clearer. There's a 7 maybe. There's a 9. That's approximately right. This is angle C. And I would say in this type of a side, start with the largest angle, because law of cosines, if you remember when we divided up, it works no matter what angle you start with. And it's often trickiest with the larger angle using the law of sines, so this will eliminate that difficulty when you get to the law of sines. You won't have the problem of needing to work with a smaller angle. It really doesn't matter where you start. But if I write this, I'm going to say 13 squared equals 7 squared plus 9 squared minus 2 times 7 times 9 times the cosine of that angle C. Well, doing the math, you get 169, 49, 81 minus 63 doubled is 126, and then cosine of C. Well, we're going to try to find what is the cosine of C, so I have to very carefully do this. This is the addition. This is multiplication in here, remember, so I can't subtract that. That's a mistake that's often made. 49 and 81 is 130, taken away from both sides, gives me 39 is equal to negative 126 cosine of C. I divide both sides by negative 126. So angle C is equal to the inverse cosine of negative 39 over 126. Well, when you plug that into your calculator, you get very close to 108 degrees. Okay? Then from there, if this is 108, you're going to set up a law of sines to solve either this one or this one. So let me sneak it in down here. I'll say the sine of 108 over 13 is going to be equal to the sine of opposite of 7 is angle A, sine of angle A over 7. And when you do that, I think, and you're going to take and find the sine, divide by 13, multiply by 7. Angle A works out to be about 31 degrees. And then you add that to 108 and you subtract, that's 139. So then angle B is going to be very close to 41 degrees. Okay, so these are all within about a degree. So that's pretty clear. You can just label your diagram when I go to correct it. If I see all those numbers written in there carefully, that will be a very clear way to give me your answers. All right, so on to this one. This looks like it's angle, side, angle. Look how it goes A, B, C. That's the included sides. So that's a length 30. And this is at an angle of 50 degrees. And this is an angle of only 19 degrees. I've made a very small drawing. But I can do the math and subtract and find that 50 and 19 is 69 degrees. So that's going to be 111. And then to set that up and solve it, I'm going to say the sine of 111 degrees over 30 is going to be equal to the sine of 19 degrees over, and opposite 19 is side C. Okay, so take and do the sine of 111 and divide that by 30, and then I'm going to take and find the sine of 19 degrees and divide by 0.3111. And I get 10.46. So that's what C is. We'll call that 10.5. And then I do the same thing for finding B, or A rather. So I'll say the sine of 111.
Eric!